Hi there, welcome back. This video we are going to understand everything about VNet integration with the app, which will include the benefits, the limitations, the subnet requirements, and the most important, how can we use VNet integration to connect to resources which lives inside the VNet. This video will include the presentation, live Visio for better illustration and understanding, creating a live web app and configuring VNet integration to access resources in or through a VNet like a VM or a PaaS service. So let's get started with the presentation first. So this presentation will cover learning about the key features, the benefits and the limitations to effectively utilize the Azure cloud service. So the purpose and key features. So we do the VNet integration to access resources within a virtual network or through a VNet like a VMs or PaaS service like a Azure MySQL servers, etc. and so on. Outbound only. So the traffic flow when we do the VNet integration with the app, only outbound traffic from the app will be affected and not the inbound. Supported environments and protocols. So in app service plan we have various pricing tiers like a basic, standard and premium V2 and V3 and elastic premium. And the app type supported will be the app service, the function app and the logic app. Protocol will be the TCP and UDP. So there are some limitations in VNet integration as well, which we need to keep in mind when we are trying to access the resources through VNet, like mounting and drive, Windows Server Active Directory domain join, and the net BIOS. There is the regional constraint as well. We need to use the VNet which is in the same region as that of the app service plan, and a dedicated subnet is required for the VNet integration, meaning you won't be able to use that particular subnet to host or any other resource. Benefits resource access through the VNet or the paired VNet or the service endpoints and the private endpoint services. We can use the networking features like the NSGs and the route tables to block or route the traffic according to your needs. So these benefits we can leverage from the VNet integration. Next we have the subnet configuration and the multi-plan subnet join. We have a dedicated subnet option here which requires a dedicated subnet which will be used for the integration. Subnet will be used for only for that particular use. And we have one more feature which is the multi-plan subnet join. In this feature we can add multiple app service plan to a single subnet, and it requires /26 subnet for this use case. So when we do the VNet integration, we have a traffic routing and control mechanisms we can use to how we want to route the traffic from the web app to the internal or the private traffic. Application routing defines if we want to route all the traffic, whether it's private or public, through the VNet, or if we just want to route the private traffic. Then we have a configuration routing. This affects app operation particularly during startup phase. So during startup, if you want to mount a drive or something like that, we can use the configuration route. So we can configure it. Then we have networking routing, that is like using the NSG and the UDR to route the outbound traffic to the external points through the NSG and UDR. Next we have access to on-premises resources. So when we do the VNet integration, we can access the on-premises resources with the features like the express route or site-to-site VPN. We can use the troubleshooting tool which we are going to discuss in the next video in detail. If we are not able to reach any resource from the VNet, how can we troubleshoot that with the commands like the ping or the NSLookup? This is a no extra charge feature, so you won't incur any charges while you are using this integration. So now let's head over to the portal and create an app service plan and a web app first, then see the what are the subnet requirements and how the VNet integration works in detail. Alright, so first to create an app service plan, we will search here. So we'll click on create. Okay, so I'll choose a subscription, the resource group. I'll give a new resource group with the name ASP, App Service Plan. I'll give a app service plan name. Then I'll choose operating system Linux. Region I'll keep Central India because my VMs are also in Central India. In the pricing plan, I'll use basic V1 because it will support the VNet integration. You can also use the feature view to understand which tier supports the VNet integration feature. So I'll use a B1, it supports. So I'll click on select and I'll go to next tag, that empty, next review and create, and then create. So what we have done right now is created an app service plan where we are going to host our web apps. Next, let's create a web app. For that, I will search for web services. I'll click on create. I'll choose the same resource group. I'll give a name app test. And I'll choose a .NET 9. It could be anything according to your needs. I'll choose Central India. So I'll use a Linux because my plan is a Linux. So you can see my plan is already coming here. I can use this one or I can create a new one. So I'm using an existing one which is a basic B1, and I'm going to go to next deployment. I'm not going to do anything here. I'm going to go next to networking. I'm not going to do anything here. I'll make the changes after the app is created. Next, review and create. So now a web app is also created. So I'll add here web app. So what we have right now is a Linux plan and a web app, right? And so the next thing which we need is a subnet. Before creating a subnet, we will understand the requirements. So the number one thing which we need to keep in mind is we need a dedicated subnet, meaning we won't be able to use anything else on that subnet other than that web apps. Next thing is whenever a new subnet is created, Azure reserves 5 IP addresses for its own use. Next thing is one IP address is used out of that subnet app service plan instance. So meaning at any point of time, if you have multiple apps in a single app service plan instance, one IP address is only going to be used from that integrated subnet. And also to keep in mind, this IP keeps on changing from that integrated subnet. It takes from there whenever there is an operation like a platform upgrades or a scaling operation happens, these IPs can change. Just to elaborate more on this, I have multiple apps on a single app service plan. All those multiple apps in which we have done the VNet integration will have a one IPs from that integrated subnet. But whenever a platform upgrade or a scaling operation happens on that app service plan, those IPs can change, but those IPs will be only from the integrated subnet. So next, if we scale our web app to 4 instances, then 4 addresses will be used from the subnet. So in earlier case, only one instance was there, so only one IPs were used. And if we scale our app service plan to 4 instances or 5 instances, then simultaneously the IPs will be used from that subnet. There is a dependency on the subnet which we allocate. Also, while creating or allocating a subnet, we need to keep in mind of the platform upgrades which also need free IPs to ensure your upgrades can happen without downtime. So subnet size can't be changed after assignment. We need to assign subnet depending upon the scale your app might reach. So the recommendation Microsoft gives to allocate IPs which is going to be the double planned maximum scale. So now to understand this statement, let's go to the app service plan and we'll go to the scale out and the manual. So you can see in this case in the basic tier we can scale up to 3 instance. So how much IPs we need to give depends upon the instance count. In this case we have 3, so we need to double this amount, and that is how much we need to allocate for our subnet so that the platform upgrades plus the scaling operation can happen without any issues. So in this we will allocate minimum 6 IPs for the app service plan effective operation. So if this would have been not a basic and a premium tier, we could scale up to 30 instances at a time. So this is the limit of the app service plan that it can scale. So the /26 subnet is the one. So if it scale ups to 30 instances, so we need to allocate minimum 60 IP addresses for the scaling process to happen effectively. So /26 subnet can suffice for all the premium tier as well. So if you're thinking that your app would scale up to 30 instances, a /26 subnet is necessary for you to use, covers the max scale of a single app service plan, because we can scale up to 30 instances, and /26 subnet provides you 64 address. We can also use a /27 and a /28 subnet, but this will provide you with less IPs. If your app requirements does meet that needs, then you can use these subnets, right? So now to understand the working, how does this work? This is app service plan and this is a web app, and this is where your app service plan is hosted. In app service plan on Azure are hosted on worker role. And the VNet integration works by mounting the virtual interfaces with the worker role with the address same as that of the integrated subnet. So what Azure does behind the scenes is use the virtual interfaces and attach it to the app worker roles where the app service plan are hosted, and also assign the same IP addresses as that of the integrated subnet so that it can communicate to the VNet resources. So these virtual interfaces we do not have access to, so Microsoft or Azure controls them. So let's use the integration subnet. So now in here we have a Linux plan and a web app hosted on this plan. We have a worker role in Azure where this plan is hosted. At Azure side, whenever we want to do the VNet integration, what Azure does is it attaches a virtual interface to the worker role with addresses same as that of integrated subnet. And also at any point of time, a single app service plan can have only 2 virtual interfaces, meaning it can attach to 2 separate subnet or VNet at a single time. So understand this working. traffic from internet goes to the web app, and if a web app wants to access any resource in a VNet like a VM or a PaaS service, etc., it needs to do a VNet integration to have that connectivity to the private services. Now, to better understand the internet properties of a single app service plan, we'll just go to a networking. In here, we can see in the inbound traffic configuration, we have a public IP address. We can reach the app with a public internet, or else we can also have a private connectivity, but for that we need to have private endpoint. In the outbound traffic configuration, we can see the VNet integration not configured yet. We'll configure that later. We can use the outbound DNS feature default Azure provided, and the outbound addresses, and these are the public addresses that your app can use to for outbound calls. So any traffic that is to the internet can be made directly through these IPs, and if we have VNet integration done, we can configure if you want to route all the traffic from the VNet or just private from the VNet. So while in the presentation we heard about one feature here, which is MPSJ subnet join. So this is a new feature introduced by Microsoft last year 2023. So what Microsoft helped in remove is earlier only one subnet can be used with a single app service plan. So at any point of time, a web app can be attached to only one subnet, but with multi-plan subnet join feature, what we can do now is we can have various app service plan connected to the same subnet, which reduces the administrative tasks. With this feature, we can use only one subnet for multiple app service plans to join them. We have to keep in mind we need the /26 subnet to use this. I'll post the command on the description section how you can enable that on your subnet. So now let's head over to the Azure portal and create a subnet for your app VNet integration. So we'll search for VNet. So I have one VNet. I'm going to use the existing one, which is a Linux VM VNet. Let's go to the subnet section, create a subnet. I'll give the name web app subnet. I'll use a /26. I'll use a /26 address, and for the NSG I'll use this Linux VM NSG, and the route table I'll leave that empty for now and add. So my subnet is created now, and I'll head over to this web app. I'll under networking section I'll head over to the outbound traffic configuration. In here I'll click on VNet integration. So I'll see an option here, add VNet integration. So my VNet is in the same region. I'll select the VNet Linux VM VNet, and the subnet, you can see web app subnet option available we can use. I'll click on connect. So now my web app will be integrated to that subnet, and I'll see various features we get when we do this integration. Meanwhile, I'll also start my virtual machine so that I can connect to this via my web app. This Linux VM is in the same VNet. I'll go back. Right. So you can see my VNet integration is done. You can see my VNet and the subnet. You can see the NAT gateway we can configure in here. We can use the NSG to block the traffic. We need to keep in mind the NSG works for only outbound traffic for this feature and not for the inbound. Inbound traffic is configured from here, and any rules placed on the NSG for the inbound will not take effect. Only the outbound calls are affected by this NSG. We can use UDR to route the traffic according to your needs, like to a firewall device, etc. So I'll click on VNet integration. You can see in here the VNet name and the subnet name and the IP address is available. Of /26 subnet, I'm getting 59 available IP addresses. Then I have application routing. This feature, when enabled, will route all the traffic from the web app through the VNet, also the internet traffic. And if you have not selected this option, only the private traffic like traffic to a VM will be routed, and the public traffic will be routed directly from the public IP addresses listed in the properties of the app. So the next configuration routing comes into picture when your apps are restarted. So whenever this happens, we can use the container image pull feature, we can use the content storage, we can use the backup restore features like Azure Blob Storage. So all this we can configure from the web app. Next, we have a virtual network routing. So we can use NSG to block outbound traffic to resources in your VNet or internet. All this we can configure here, and we can use the route table to route the traffic according to our needs, like to a firewall device, etc. So this is how we can do the VNet integration, and the concepts actually works. When we understand about the limitation, there are some limitations with using the VNet integration. Like you cannot use the VNet integration feature in the free tier of the app service plan. For all the updated limitations, I'll post a Microsoft link on the description so that you can check that live directly. You can reach your on-premises resources with the integration as well. No extra setup is required if you already have set up the site-to-site VPN or you're using express route connection to your on-prem resources. If you're using the two VNets and they are already paired, you don't have to do any more configuration. You can reach those resources across VNets from your app. Connecting and disconnecting your VNet is at the app level. You cannot do that at your app service plan. You can check the private IP address assigned. To check the private IP of the Linux app, we'll go to Advanced Tool. Then we'll go to SSH. We'll paste this value in here. This will fetch you the private IP of your app. In this case, you can see this is our private IP of the web app. Also now, if I want to connect to the private IP of my Linux VM in my VNet, I'll copy this IP address and type the command. So you can see it's connected to this IP, so I can access my VM through the web app. So this is how we can leverage Vnet integration in the app to connect to the resources which lives inside the Vnet or through the paired Vnet connections. It could be a private endpoint or express route connection to which connects to an on-prem environment. So also you can see in this diagram we have an app service plan and a web app which is connected via internet, and we have done the Vnet integration which is accessing the VM through the integration, and also the service endpoints, the private endpoints, and the express route connection, the on-prem resources. So I'll summarize this video for now, and in the next video we are going to cover the issues which we might face during this VNet integration and the troubleshooting steps we can follow to resolve them. I'll post the important links in the description section so you can check that document to have a more detailed understanding on this feature. Thanks everyone, and see you in the next one.